So today, what we are talking about, we're talking about triangles. Some of it's going to be new, some of it's going to be old. It's just kind of all thrown together on this document. First thing that you guys are looking at is this picture right here. This is actually a proof. Anybody know what a proof is? What does the word proof mean? Nobody? Could you use it in a sentence? Okay, and what do you need for proof? What?
Evidence.
Evidence. Okay, so this is a mathematical proof of something. This explains something. This is where we get, what am I looking for? Oh, I'm drawing a blank, you guys.
Is this to prove that it's a triangle again?
Not to prove that it's a triangle, there's something else that it's proving. There's a formula that comes out of this picture right here. Yes?
Is it the
Pythagorean theorem. Why would you say it's the Pythagorean theorem? How does this prove the Pythagorean theorem? She's right, by the way. So I want you guys to start looking at this. How is this going to prove the Pythagorean theorem? So first of all, what's the Pythagorean theorem? A squared plus B squared equals C squared. So way back, I don't even know how long ago, hundreds of years ago, this was enough to prove that this is true. That A squared plus B squared will equal C squared. So what does it mean to actually square something? Well, it means to make a square. So what is the side length of this triangle right here? 3, good. And what's the side length of this? 4, and this? 5. So then if you were to square those sides, that means to actually make a square. So what is 3 squared? We could count the boxes in here. We know 3 times 3. 9. What about this one? 16. And this one? 25. And so they saw this and they tried it out for a few right triangles and they said, hey, this is true right here. This is the proof. There's other proofs, mathematical proofs with words, but this is a visual one. Okay, so this is one way that they proved the Pythagorean theorem. So like I said, this is something we already knew, but we're going to go over it. And the other thing I want to go over on this triangle, we're going to label the hypotenuse and the legs. Does anybody know which side is the hypotenuse? Yes, Evelyn. The longer side, the one that's across from the 90 degrees, this is the hypotenuse. And is this your A, B, or A, B, or C? Your C. This is always your C. Okay, good. And then the other sides, you guys know what those are called? I already said it, but legs. So, and it doesn't matter which one you label, but these are your legs. So we're talking a little bit about Pythagorean theorem. Some of this might be new, some of it not. Questions about this so far? Okay. So down below in this chart, these are called Pythagorean triples. People in construction typically will have these memorized. The reason they're special, the reason that these Pythagorean theorems are special is because these are the whole numbers that will make up right triangles. So let's look, for example, what was the side lengths of this right triangle? Up here? 3, 4, and 5. All whole numbers, right? And so this would be important for people in construction because why would we want to measure something that was in decimal, right? It would be nice just to have a nice whole number. So maybe if you were making like a roof or something like that, you would want to know the whole number. So all of these whole numbers, so 3, 4, and 5, that will make a right triangle. 5, 12, and 13, we could test that out. So 5 squared would be 25, 12 squared is 144, and 13 is 169. So 25 plus 144 okay, equals 169. I can't make this. Okay. And if we were to go and try that, they would work for all of these. So those are our triples. Does this make sense? Yeah. Can we come up with 4 others? Let's see. Is there a pattern from 3, 4, 5 to 6, 8, 10? What happened? Doubled it. So could we come up with another set based on that? See if you can come up with another set. Am I confusing? Yeah. So if you can see a pattern there, you don't need to have all these triples memorized. If you have the first 4 up at the top memorized, you could come up with other triples by doubling the numbers. So you're going to want to make sure that you're doubling. Maybe I didn't make that clear enough. We are doubling things. So double 6, it would be 12. Double 8, it would be 16. Double 10, it would be 20. So this would be 1. And again, you could test it out. Make sure 144 plus 256 equals 400. That should be true. Okay. Doubling this. 20, 48, and 52. So again, if you just had this memorized, you could come up with other right triangles by doubling. Any questions? No. Easy peasy. Let's go ahead and go to the next. So these are not going to be necessarily triples that we are going to find here. So it might not be a whole number. It might be a decimal number. Are you guys doing this?
I'm already done.
You got this answer? No? Okay. Okay, so here's our right triangle. Well, we have 2. Why did I outline it in black? Here we have 1 right triangle, and then here we have another right triangle. So we're going to have to find the missing side length for both of these. So we could call this, let's start with this purple triangle first. We'll just call that A. So which one's our hypotenuse? The 14, the 12, or the A? 14. So we need to set up an equation like this. A squared plus 12 squared equals 14 squared, and solve so that we can get part of x. You're going to do the same thing with the other green triangle. Yeah, we can work on approximating. Okay, do the next one if you don't know. What did we get that a equals square root of 52? Let's just leave it like that and get to the green one. Which one's going to be my hypotenuse for the green? 29. We'll call this b, I guess. So b squared plus 12 squared was 29 squared. I don't know. I don't have that one memorized.
That's a 9.
Yeah, that's a 29.
Oh, I was looking at the
I don't know. Multiply it out. Old school. You guys remember how to multiply double digits?
No. You don't? No, I haven't done. I always use just calculator. Oh gosh.
Okay. 9 times 9?
81.
Okay. 9 times 2? 18 plus 8?
26.
Put a 0 down here. 2 times 9?
I haven't done that so many.
2 times 2 plus 1? Or is this not how you guys learned how to multiply?
I haven't done that in so long. 2 plus 5 is 7.
Good, good. Yes.
No, you have to go. No.
Oh, yeah, I carried it.
What?
6 plus 8 is 14. Oh, there's that little dash. There you go. I'm not doing that one for you.
I don't know.
Wait, well, I did that so wrong. I hate subtraction. I just messed myself up. Is that right? I'm starting over.
We're going to do double digit multiplication.
No. Why can't we use a calculator? Yeah, why are we? Wait, would that be a 0 then? And that's 11. I forgot how to
That's 11, that was just 3.
Got it right, because in here's 2. Okay. Is that 7, 8? No. I just said, oh no. Hold on, I'm working. Did I get 9? It's not. Why'd you look at me? Do I have the answer right now for you? Yeah. 7. It worked. Stop looking at me. It's freaking me out.
Did we get it?
Yes.
Okay, what is it?
697. Yeah. Square root of 697.
Okay, perfect.
Is that it? Is that our answer?
Is it? What's x equal?
Oh.
The square root of 52 plus the square root of 697.
What?
Oh,
Okay. Well, I don't have any room for this.
Do we have to solve the square?
Do I just add the 52 and the 697 together?
No.
Yeah, because it's A and B.
No.
Wait, what?
Yeah.
No, you
Yes.
Do I just add those two together and then put it under a square root?
But A and B, they're different.
Okay, but so I'm trying to find x, and so here's A and here's B.
Yeah.
So I'm adding A and B together.
So you do add them together. What? I don't like your trick question.
It's not a trick question.
Yes, it is. Yes, it is.
How is it a trick question?
know the answer?
Yes, it's
Yes.
Justin Cole, but like
It's a trick question because Justin's not here. He's the only one that knows it.
It's not going to be.
yes, because yes.
If Cole doesn't know it, I'm not gonna ever figure it out.
Yes.
So what do you think? What's the final answer?
Yes.
Yes, what? No, what's the yes is the final answer? What's the final answer?
Oh,
Yes.
you were asking if that's how you solve it. It's
349.
749.
Yes is the right answer.
749. It's the square root of 749.
So this is saying square root of 749?
No.
That is what Avery said.
Eddie?
No.
That was you. No,
That
you
was
have
you.
to find the square
Is
root
this my
first.
final answer?
Yes. No, you have to simplify.
No, because you have to find the square roots first.
Okay, that's what. Yeah, maybe it was a little trickery. I don't know.
I love trick question.
Okay, square root of 52 approximately.
7.5. I don't know.
7.2. Good. Square root of 697.
A number.
Okay. What's 20 times 20?
400.
400. So 400. What about 30 times 30?
600. I mean 900. I mean
900. So 400 and 900. So where would we think that would be about?
225.
It's 26.4.
26?
26.4. So we have 7.2. Oops.
That is wrong.
7.2 plus 26.4.
which is 30. 30. Yeah.
Yeah, 33.6. I
Boom.
did that myself. I don't know.
Okay. Do you guys remember how to simplify using radicals, though, that we talked about before? Because on your homework, you're going to have to do it that way instead of decimals.
Yeah.
Okay.
Is that what we did last week?
Yeah.
Like the.
Are we just allowed to use a calculator on our homework?
I mean, we're at home, so.
I don't want you to.
I'm just saying.
Okay.
I have my phone.
We got to get through this. Quickly. Which one are we going to figure out first?
A. No, B, because
B.
there's two other sides.
Yep. Go ahead and find B.
Oh gosh.
Go ahead and find B. I will give this to you. So it should be 256 plus B squared equals, 625. Just so we can be a little bit quicker about it. Okay, what did we get? Square root what? 3 what? 369, yes.
Yeah, what they said.
So what do we think that's approximately?
Oh, what?
Well, what's 20?
400.
400, okay. So it's less than 20 at least.
15.
19 is 361, so this is 19.2.
Yeah, I was right.
Do you have all the memorized? Like up to like.
No, I have the answer. No.
So what you're saying is we should just memorize the answer.
Yes. Yes.
You should have the other ones memorized. Okay, so now we have to use that to figure out A. Okay, so here, I'll give it to you as well. So this is going to be A squared plus 368.64. Because we approximated this. I guess we could have used 369. Let's just use 369. That would be easier. 369 equals 22. I don't have that one memorized. 484. There you are.
Okay,
Oh, yeah.
more subtraction.
Yes, more subtraction. How is what an A? This?
I don't think they're on the same problem.
This? This? Okay, well then use an O.
14 minutes.
Then it's 0.
I know.
Do 0 makes so much
No.
sense.
I saw that in my head the second you said it, and it was really
14
creepy.
plus 9. That is 14. That is 14. Yeah. So it is 5. Okay.
So what do we get? Square root what?
I just erased my answer.
Okay, can we approximate this one?
10 point something.
10.5. 10.6.
10.7.
10 point.
Yeah.
Wait, that's
7?
higher.
I was gonna say 5.
Oh wait, no, mine might be off because I used a decimal. It might be less than that. I don't know. Let's just say 10.7. That'll be great. Okay. I think we might just skip the next one because you guys know how to use this stuff. Let's get to something that we don't know so we can hurry up and get to homework so we don't have homework. How about that? Okay, do you guys remember last time triangle inequality theorem? Can you tell me if this is a triangle?
Yes.
Yes, you can tell me, or yes, it is. Which one?
It is a triangle.
I'm testing it. Just give me a second.
How?
Because 7.
Oh, you mean
Yes,
this
it
one
is.
right here? We talking about this one.
It is because when you add all of them together, it's great.
So do we all agree that it is a triangle?
What are we talking about? This triangle. Oh, that triangle. Okay. Yes, it is a triangle.
Oh, so it's great. Oh, wait, never mind. Oh,
What?
Oh no.
No. Okay, so moving on. So we can get some new stuff. So not only can you tell if something is a triangle by their side lengths, you can also tell if it is a acute triangle, a right triangle, or an obtuse triangle. We know what those all are, right? Don't need to review that. And if you do, just read the definition. Okay, so in order to figure out if it's a right triangle, we know that it has to be c squared equals a squared plus b squared. I'd like you to write it this way. I know it seems backwards. You'll see why it makes maybe a little bit more sense in a moment. So if you test the side lengths and c squared is equal to a squared plus b squared, then it's a right triangle. Questions about that? That we've known. The new information is if it's an acute triangle, then c squared is going to be less than a squared plus b squared. Anybody have any guesses on what you think obtuse is going to be?
Greater than.
Greater than. So c squared is greater than a squared plus b squared. So I think it just kind of helps to remember if we set it in that order. If we put the c squared first. That's the only reason that we do this. So what I would like you to do on the next one, you are going to determine, is this a triangle? So 7, 15, 21, is that a triangle?
You just write yes.
Yeah. Yes or no? You can do it in your head.
yes, it's a triangle.
Yes. So if it's yes, it's a triangle, then I need to know, is it acute, obtuse, or right? Okay. Your C is always going to be the largest number. So this is your A, this is your B, and this is your C. Okay. So 21 will always be, well, not 21, but the longest side will always be your C. So the way you're going to set it up is 21 squared, and then I usually just leave this blank because it's either going to be less than, equal, or greater than. And then 7 squared plus 15 squared. 21 squared, I'll give it to you. 441.
You should ask for 7 squared.
7 squared is?
No, 49 and 225.
I would say yes.
What?
Oh,
I'm gonna
got
say
it.
yes, it is.
So, is it less than, equal, or greater than?
Greater
Greater than. So what kind of triangle is this?
obtuse.
Yes, obtuse triangle. Perfect. If it's not a triangle, can you figure out if it's acute or obtuse? No. So if one of these is not a triangle, you don't have to figure out what kind it is. That just wouldn't make any sense. Oh. I gotta post your assignment.
2 is not a triangle.
Is 2 a triangle?
No. So if it's not a triangle, does that mean we don't have to?
We just write no.
If it's not a triangle, we can't tell if it's obtuse or acute.
So just right now.
No, we'll move on. Let me just give you the squared for all of these as well. So the last one is a triangle, and 15 is 225, 20 is 400, and 24 is, what did I do? Oh, 576. And then you can figure out if it's acute or obtuse or right triangle. I'm gonna post your assignment. What do we got? You got caps?
I think I do.
I think you do.
In my ID.
I have them probably if he doesn't have it. Do we do this? Or do we do?
Yeah.
Are we done? Darn it. I'm gonna forget this.
Awesome.
Oh, we're supposed to show you.
What did we get, you guys? What kind of triangle is it? Acute triangle. Perfect.